So let's go straight into the subject from now. So my name is Laetitia Avro. I'm a DBA for more than 10 years. I mean a Postgres DBA because I first began with Postgres and then I had to learn Oracle, SQL Server, and even some DB2. But I don't say that a lot because I don't want to do DB2 again. I'm a PostgreSQL Code of Conduct Committee member. I'm Postgres Women co-founder, and I'm actually a NEDB Senior Database Consultant. You can follow me on Twitter. About this conf talk, you will see that my slides are quite clear without any words or just not more than 5 words. If you're more comfortable with a more wordy presentation, you can have my slides from my blog, mydba.blog.org. You will find a conf talk, a link where you will find my slides and you will be able to see the annotated version of my slides. So what about the SQL standard? First, when I wanted to read the SQL standard, you should ask yourself why you want to do that thing. And the first reason I come with was because. And the second one was because a lot of people told me don't do that, so I really wanted to do that. And the third one is the most serious one is because I really think that as a scientist, I need to be curious. I really need to learn what I don't know. And of course, I won't be able to learn everything in the world, but I will try to learn as much as I can. So who here likes to write SQL queries? Yeah, okay, not so. And who likes to read and correct an SQL query written by somebody else? Yeah, no one, that's what I thought. So it comes because SQL is a language, but it's different. It's different because you don't have to explain the computer how to do things. You just have to explain to it what you want. And that's the most difficult part because actually we don't know what we want. And as I said already, SQL is a programming language. It's code. It's real code. So as in any code writing, you need to put some rules, like you need to take care of indentation. You need to take care of carriage returns. You need to take care of comments, because it's really code. And if you're not convinced that it's code, just to say that SQL is Turing complete. You will find on Postgres Wiki a wonderful demonstration of the Turing completeness of SQL. And being Turing complete, it means that if you're crazy enough, there is no code problem you can't solve with SQL. And I really emphasize on being crazy enough. But I don't know if you know that thing about Advent of Code. It's a code contest during December where every day you have another coding problem relating to elves and santas and so on. And in 2017, Vic Froing, who's in Postgres community, decided to solve each and every problem in SQL. And you will find on the annotated version the link to his code. And I really strongly encourage you to go see and read his code. You could even try to write SQL query to solve that kind of coding problem. But just by reading the link, I'm sure you will learn a lot of things. About the SQL standard. So SQL standard was first out in '86. And then they had this wonderful thought that in '89, they came out with another version, and they said, this will completely cancel and replace the previous version. And they decided that from now on, each new version of the standard will completely cancel and replace the previous version. It means that we, in theory, we could have a completely new SQL standard that completely breaks everything. Of course, they won't do it, but in theory, they could. We had then another version in '92, and I don't know why, but people got stuck in '92. So just to be sure we understand what '92 means, is it was a place in history when the most used operating system was Windows 3.1. Do you remember that? Do you even know this happened? So I'm sure that a lot of things evolved since Windows 3.1, and it's the same thing with the SQL standard. For example, we had SQL standard 99, and then it was a big step because that's where SQL standard decided to take a break with relational algebra. And that's really important because in relational algebra, you had that thing which said that when you store data, it needs to be atomic. But what does atomic mean? When I'm storing a string, is that atomic? Because I can split a string in 2 characters, so it's not atomic. And then a character is not atomic either, because I can split it into a list of bits. But would it be efficient to store a list, 1 column by bits? I'm not sure of it. That's where the SQL standard decided to add more complex data types, like arrays, and later like JSON, like XML, that was quite hype in 2000, and so on. And so just to be sure that, I don't know if it's the same thing in the United States, but in France, in university, people are still teaching SQL 92. So it's, they are late because there was 99, 2003, 2006, 2008, 2011, 2013, 2016. And another one is coming. So they're very late. And there are so many things people don't know about SQL. And it's a shame. It's a complete shame, because with the right knowledge, you could simplify your query, and you could have better code. So for this presentation, you won't master SQL, and I'm not sure there is anybody on earth that can say, I'm mastering SQL. But what I can say is I will try to show you some features you might not be aware of and that can help you. To do that, I tried to find some examples, and I used the data model from pgexercises.com. If you don't know this website, you really need to go. It's really good, and it's really gradating. You have the first exercises are really, really easy. The last ones are really, really, really hard. And if you think that you suck and you won't be able to do even the first exercises, my 10-year-old daughter can do them, so I'm sure you can. And if you think that you are a complete SQL master, just go to the last exercises, and then you will find some humility, and you will be able to learn. So about the data model, it's simple. It's a way to store booking facilities for a countryside club. So we have a list of members. We have a booking table, and we have a facilities table. So that's quite simple. First exercise, we will try to get all the members with their recommendee, because in country club, in a lot of country clubs, you can't become a member like that. You have to be recommended by someone else. So, how to do that? I think that the first obvious thing to say is to do a self-joins. So what's a self-join? First, you will write what you want to get as a result, so the first name and the third name of the member. And then you will fetch their recommendee first name and surname. What you can see is we're doing a join on the same table. That's why it's called a self-join. That's pretty easy. Self-join are a table join with itself. It's available as left, right, and internal joins. And it has always existed in the SQL standard. It has always been allowed. Then we go with subqueries. So we keep the first, the same base. We want the first name and the surname of the member. And then we will do a subquery to fetch the first name and the surname of the members that recommended that member. So a subquery inside a select clause. It can display a subquery result only for scalar subqueries. How does SQL standard write that down? So you will see it's scary if you don't know the SQL standard, but you don't have to be scared. Fear will only prevent you from doing amazing things. So just follow my lead. It's not that difficult. So here how the SQL standard decided what's select, query specification. So you have the keyword select, and then you can have a set quantifier as a star, and you have the select list and some kind of table expression. What's the select list? The select list is an asterisk or a select sublist. The pipe here is the or. And you can have other select sublist chains with commas. A select sublist is a derived column, so that won't help us at all. But that's how the SQL standard works. Sometimes you have huge steps, and sometimes you have baby steps. You just have to be patient. So what's a derived column? It's a value expression, and that don't help us better. But a value expression is a whole lot of things. And in the middle of these whole things, we have a reference value expression. A reference value expression is a value expression primary that won't help us, but a value expression primary is a non-parent-sized value expression primary, or a parent-sized value expression, but a parent-sized value expression is just a value expression primary with parentheses. So we can loop on that for a while, but it won't help us. Then the non-parent-sized value expression primary is a lot of things, and it's so many things that it won't fit on my slides. But here, what we're interested in, it's a scalar subquery. What's a scalar subquery? It's a subquery, thanks to the SQL standard. And a subquery is a query expression between parentheses. But we have a constraint here is the degree of a scalar subquery shall be 1, meaning that the result of the query can only be 1 row, 1 column, and no more than that. So if you're thinking as a developer and as a SQL developer, it means that. You can't have more than 1 column, and you can't have more than 1 row in the result. CTE, common table expression. It's another way to write subqueries, and it's better for human readiness. So we begin again, with the same query, we select the first name and the surname of the member, and then we will try to find who recommended that person. And we do it like that. So what I like to say is CTE are like temporary views. It's only for that query, and you can use it several times in that query, but you won't be able to use it in another query. So you just describe and give a name to your CTE, and then you put your query inside it. And then you can use it in the select and in the where clause. That's pretty efficient until Postgres 12. We had some problem with that because sometimes it leads to performance issue. So the advice I give my customers is always go with CTEs, and if you find performance issue, go with a subquery. But it's so easier for a human to read because you have first the subquery, and that's what a human needs to read at first. And then you have a name on it. And as always in code writing, just choose a really accurate name for your objects, and you will be fine. So commentable expression are some kind of declared subqueries, and they were introduced in SQL 99 standard. How does the standard describe them? So in the query expression, before anything, you have a with clause. And this with clause is described as with an optional keyword, which is recursive, and a with list. This with list is a lot of one or several with list elements separated by commas. And then this with list element is the keyword as and the table subquery. So just note that the as keyword is not optional here. And it's really a shame because in a select and in a where clause, the as keyword is optional. So it's quite confusing that here it's not. So what I say always is always use the as keyword even if it's optional. So for a developer, again, it sums up like that. And I really encourage you to practice writing CTE because it's really good, and it's really better to be read when you're maintaining code and so on. So the next one is if we take the query we had before, did anybody notice that there was this weird concatenation thing? No? Because it's kind of weird to write it like that instead of having 4 columns. Well, I wanted to show you subqueries, and we see that subqueries in the select clause are always scalar. You can't have multiple columns in your subqueries in the select clause. So you are not allowed to write things like that. You shouldn't write things like that. And so it comes with lateral join, and I'm sorry about the picture because it's a French joke. And I couldn't find a way to translate it into English, so I'm very sorry about that. So if I take, again, the beginning of my query, I have the first name and the surname of my member, and then I will get the first name and the surname of the recommender. And I find the recommender by doing a lateral join. And the lateral join is a join where, of course, I use the recommended by with the mem ID of the mentors. And I have this weird join condition on true because I've made my join condition on the subselect. So I don't need to add another one. Lateral join are really, really highly addictive. You should use a lateral join each time you think for each row I'd like. But we have a brain that is such well done that we always think that for each row I'd like to. So sometimes it's very great, and I really encourage you to practice writing lateral joins, but sometimes you have a simpler way to do that. And like in any field, simple is better. So if you can do it on a simpler way, do it. It appears in the SQL standard in '99. And the SQL standard says that it's in the query expression body. And a query expression body is a lot of things, but it can be a join table. A join table is several things, but it can be a qualified join. And a qualified join is a table reference, a join type is inner or outer, the keyword join, and another table reference. And in that table reference, you can have a table primary. So as I said, SQL standard can be quite boring, but you just need to be patient. So the table primary is a lot of things. But amongst all the things, and you can see that the as keyword is optional here, you have a lateral derived table. A lateral derived table is the keyword lateral with a left parent, meaning a left parenthesis, and a query expression and the closing parenthesis. For those who are not sure, you can do a join condition with a Boolean. Join condition can be is the keyword on with a search condition, and that search condition can be a Boolean value expression. And in that Boolean value expression, you will see tomorrow that you can have any literal Boolean value expression like true, false, and unknown. So let's do something else. Let's try to get the list of members whose name is David, Tim, or Darren. So when I gave that exercise to my daughter, she came out with a solution that's completely crazy, but it works. So she decided to go that way. So I said to her, and if you have more than 50 names, what will you do? And she said, I will write 50 conditions. And OK, it works. I'm not sure any developer would write it that way, because we've got in. So in is pretty great when you have a constant value. And this constant, and you show that this constant value won't be null. And you will see tomorrow why it's broken with null. But there's another way to do things. It's values. So I'm sure you know values in an insert into statement. But did you know that SQL standard don't allow to create a SQL statement, a select statement, without a from clause? In Postgres, we can do that. We can do select hello world. It's not SQL compliant. The right way to do a hello world in SQL standard is values hello world. And values is a way to create what I call constant table, meaning a table made out of constants. So how you could use that to fetch the list, the member that are called David, Darren, and I don't know the third name. I'm sure he won't, he will pardon me. So values. You begin with what you want, meaning you want the first name and the third name of the member, and then you will inner join with the constant table with the name you wanted. And okay, that's weird for a lot of people. What I experience is a lot of time when there are only a few constances, it's not so good. It's better to use an in statement. But if you have a whole lot of constants in your in statement, sometimes this, the value thing is better and it will run faster. I couldn't find why it did that way. So values. It can be used to lower network overhead during inserts, as you know, and you can use it to tune some in-word clauses. And it's available since SQL 92. How is it described? So it's in the non-join query expression, and in the non-join query expression, you can find a non-join query term. And a non-join query term can be a non-join query primary. So again, we're taking baby steps. With non-join query primary, you can have a simple table. And a simple table can be a table value constructor. And a table value constructor is values with a table value constructor list, which is what we see before. Let's try another exercise. We will get the list of members who never booked an equipment, because it can be very accurate to have that, because those members are very profitable for the country club, because they pay their fee and they never use the equipment. So how would you do that in SQL? The obvious answer is to use not in. So you begin with the surname and the first name of the member, and then you will use a not in with the subquery. It can be a good thing. It can be a nightmare in case of you have a null value in it, and you will see again why tomorrow. You can use not exist. It sometimes performs better than not in, and that's how you write this. So obviously you're selecting one because you don't care about the results. You just want to know if this row exists. And you will put the join condition on the where clause of the subquery. And it's very efficient. But there is another way to do. It's called anti-join. Anti-join are joins, left join, where you will select when the other side is null. It really performs very well because in Postgres, because Postgres planner knows about anti-join. Some other RDBMS don't have that luck, and they won't perform better with anti-join. So as usual, with optimization, you need to bench to be sure it's a good thing. So now we will go to the kind of BI things, because, well, the thing of the guy with BI always come up with these weird queries that are very time-consuming, and, well, here we have an example of something that can be asked. It's for the year 2012, they want to know how much an equipment was used per month. You have the slots. The slot is a number, and each slot has a duration of 30 minutes. And so they want for the year, for each equipment, the duration of use per month. And then they want the total per year, and then they want the whole total for all equipment and for the year. So you can do that with 3 queries, obviously. So you have the first one. We will fetch the data for each equipment and each month. And then you will have another query to have the data for each equipment for a year. And then you will have the third query who will sum it up. and you will have everything. And I added some nulls value when the data was not relevant. So it works, but it's not very efficient. And then we come with rollup. Rollup is a way to aggregate data, and it works with hierarchical data. So you will write it that way. It's in the group by. You will say how you will group by. So I want things to be grouped by equipment, and they by months. And then, because I want my results to be fancy, I will add another by clause. Rollup are different from cube because cube won't know about the hierarchy of data, and it will try to sum things up for every combination possible. And rollup came up in the SQL standard in 1999. How is it written? So obviously it's in the group by specification. And in grouping specification, you will find something called a rollup list. And a rollup list is the left parenthesis, a grouping column reference list, which is just columns separated by commas, and a right parenthesis. It will take the, as I said, rollup is for hierarchical data, so you really need to take care in what order you will put your column in that list. It's really important. Then let's say that for each member, we want to display their first and last name along with the total number of members in the club. That's completely crazy. But for example, I would like to have first name, surname, and then 47, 47 being the total number of members of my club. So how would you do that? Again, you can use a subquery. So you will put a subquery with a count equal. As it's only one column, you can put it in a select clause because it's a scalar subquery. And then you will have the first name and the surname of the members. That will work, but we have so many options, and we can do much better to have a query doing that. And it's called window functions. So window functions could make a whole conf talk, could be a subject for a 1 hour talk by itself. So we will only discuss in a shallow way. So I will tell you it exists, and then I will trust you to go see how it can be used. So we begin with the count, and then the first name and the surname, and we will say how we want to count. Here, as we want to count everything, it's we won't group over any column. We have the over without anything in it. But you could say that you want to group things in another way, and you will have them really nicely. It's pretty efficient, and I can't encourage you enough to go see what window functions can do for you. It's really a must-see thing in the SQL standard. So it can data aggregate, and it can aggregate data on columns that are not displayed in your select clause. Because normally, if you do a data aggregation in a group by clause, you need to display these columns in your select. And on the other way around, if you had non-aggregate columns in your select, they need to be in your group by clause, except for MySQL, and well, it's not SQL compliant. It appears in SQL 2003. But in SQL 2011, something wonderful happened. SQL standard added 2 functions and other, but 2 really important functions. It's aggregate functions that can help you with, the thing you say, oh, I want to compare that row with the previous row or with the next row. These functions are lead and lag, and you can really use them pretty efficiently, and it will help you compare your row with the previous or the next row in an order you will define in your window function clause. So here, the window function is defined as a window function type, the keyword over, and a window name or specification. If you can name your window, it means that you can reuse them. You can use the same window in several window functions, and that's pretty great. Window name or specification is either a window name or an inline window specification. So that's thanks to Captain Obvious. And then inline window specification is a window specification. That's really useful. A window specification is a window specification details between parentheses. So that's, again, very useful. And a window specification detail is either an existing window name, a window partition clause, or a window order clause. And no, it's not or, it's and, because there's no pipe. And a window frame clause. But all of them are optional. You remember I use the over without anything in it, and it's allowed because everything is optional in it. Then I said that a member can be recommended, and we already got a list of the members with the people that had recommended them directly. Now, what if I took the member of ID 27 and I wanted to know who recommended that guy and who recommended the guy that recommended that guy, and so on until there's no recommenders? How would I do that? And that's where SQL is really, really powerful. It's recursive city. Do you remember when I explained how city were described in the SQL standard? There was this recursive keyword. So we will use it. It's here. So first, I do as if I knew who I had the list of the recommenders. That's what I do in the query under. And then I will write how to get to that recommenders, and so on. So chain list of recommenders. So first, you begin with the ID 27. And then you will union all with a join on the recommenders. And it will go fetch the recommender of ID 27 and then the recommender of the recommender of ID 7 and so on until it's over. It's pretty efficient, and that's the functionality that made SQL standard Turing complete. There's another thing I want to know, to say about the recursive keyword. The recursive keyword in the SQL standard is optional, but they didn't say if it was optional because obviously you can have city without having a recursive city, or because even with a recursive city, it's not mandatory. So Oracle decided that it was always optional. And so you can get rid of the recursive keyword in Oracle to do a recursive city. It's not the same as Postgres. Postgres decided that we needed the recursive keyword. I think it's a good thing because that way you won't mess things up and go with a recursive city if you don't want to. So as a conclusion, and of course any good slide deck needs a unicorn, I wanted to just state again that SQL is code. SQL is a programming language, and you really need to see it that way. And that way you will write better queries just by knowing that fact. And then I will point you to some URLs I find very interesting. The first one is pgexercises.com. I already talked about it. And it's really a great way to improve your writing of a SQL query. The second one is the excellent website from Marcus Venat, modernsql.com, where he goes through SQL standards. He analyzes what's well written, what's wrongly written in the several RDBMS, and how they implement the SQL standard. And you will find a lot of interesting things there. And the last one I wanted to show you is the book written by Dimitri Fontaine, which is French, obviously, about it's called The Art of PostgreSQL, and I'm sure that every developer would be better by reading this book. It's really amazing, a lot of tricks, a lot of simpler way to think about things, and so on. And what I wanted to add simply is just remember to click on the feedback URL. You will find it in the PostgresOpen website, and it's on my annotated slides too. So thank you for listening, and thank you for your time.